Good afternoon, everyone, and welcome to today's webinar on the future of endpoint security powered by AI. My name is Maizi Den from MBCOM marketing team, and I'm delighted to be your host for today. Before we get started, a few quick notes. Please keep your microphone muted during the session and feel free to use the chat box to submit any questions. We will be having dedicated time for Q&A at the end of the session. It's my pleasure to introduce our speakers for today's session, Ahmed Hashim, who's our sales engineer at MBCOM. Ahmed has extensive experience in cybersecurity, and he will be walking us through key topics on today's webinar. Please join me in welcoming Ahmed.
Thank you, Mai, for the introduction. Thank you so much. Let me first of all quickly start by sharing my screen and make sure that everyone can see it, and if you can confirm. Okay.
Perfect. We can see your screen, Ahmed.
Perfect. So thank you, Mai, again for the introduction. Hello, everyone. My name, as Mai has mentioned, Ahmed Hashim, and I'm more on the endpoint security focused product. So as a subject matter expert, working with MBCOM team and focusing on the META region. So today is one of the interesting topics that we're going to cover. Something that is widely being discussed across all customers and partners, which is artificial intelligence. And today's session, hopefully, we're going to cover how Symantec uses AI to enhance protection, detection, and response capabilities, and to understand what types of features we have implemented recently, along with the evolution of machine learning when it comes to the previous establishment of artificial intelligence in various aspects. So today's agenda is going to be, let me just slip over to the next slide. Today's agenda, as you can see, is going to start with a quick history or a talk about the evolution of machine learning in Symantec endpoint security, how Symantec has been using artificial intelligence throughout a couple of decades now to enhance its protection features, in addition to two of the unique and key differentiator components when it comes to proactive protection and predicting attackers' moves with adaptive security and predictive incidents. And then we're going to talk about some of the AI capabilities, both of the agentic and Gen AI capabilities that were introduced and enhanced on the Cloud ICDM portal. And finally, hopefully, we'll have a quick and small demo and then a Q&A section for your questions and to answer. So with that said, let's start with a quick, brief history of the evolution of machine learning in Symantec endpoint security. And just first of all, machine learning is a subcomponent of artificial intelligence. It's something that is not new to Symantec. So it's been used for a couple of decades now, as mentioned earlier, and it has been enhancing protection features across the entire SEP protection stack. So for example, from a file scanning perspective, whenever we're trying to scan files, we're not only relying on manual or signature-based detections, but also we utilize machine learning to enhance the protection capabilities, where we have millions of files that are submitted on as telemetries to Symantec data lake. All of these millions of files are being ingested into machine learning models to identify patterns of what a good file looks like versus a bad file. The output is always a machine learning model that can identify with immediate response actions whether a file has bad characteristics or a non-good characteristics, for example, and enhances the file scanning capabilities and allows us to immediately take the action that is needed to block the file if it's malicious. Additionally, from a behavioral aspect as well, machine learning is there. So we have as well millions of behavioral patterns that are being collected and detected across all our customers across the globe. And with all these behavioral telemetries that we're collecting, we're also ingesting them into machine learning training models to understand how a good application behaves versus a malicious process, for example. And whenever a match on any of the patterns for a bad malicious activity is happening, it triggers and blocks the malicious process from execution. We go one step further to the reputation functionality, which mostly relies on characteristics of the file. So we're looking at various attributes, a huge list of attributes, including, for example, how many times have we seen this file, for example, in the community, or how many times have this file been downloaded. So we look at these attributes, we filter them and label them. When we get these ingested into the machine learning model, again, we get some outputs related to what a good characteristics file looks like in comparison to a bad file. And actions are taken based on the machine learning model as well. For sandboxing as well, that's where we're submitting files for detonation. We execute files in a safe environment. All the activities that is observed by the file execution. For example, when processes are launching, when files are being modified or created, all the attributes of the different file execution are being recorded. And we use machine learning to implement or to get an output of a detailed reporting of what this file was trying to do and how did it execute in the form of the sandbox detonation. So with that all said as well, finally we have the cloud analytics, which is one core component that has been there for a couple of years now. When we speak of cloud analytics, it's not only focusing on single sets of events, but rather a collective set of information that we analyze and investigate. So for example, what files we're trying to modify in parallel, what processes were trying to be executed, and what fashion are they executing as well, and in what form, in addition to what endpoint activities we have observed during this execution. So it's more of a collective information gathering across multiple aspects so that we can create an incident that provides us with all the information about a historical event of execution that happened or occurred. So machine learning, as we've said, has already been established and it has expanded throughout the recent years. And Symantec has already released some of the new key differentiator features that heavily use artificial intelligence as well to enhance the protection posture for any customer or organization. So for example, adaptive security, which has been there for as well a couple of years, but recently throughout the years, adaptations and new enhancements were included. So with adaptive security, our main goal is to reduce the attack surface by limiting how attackers misuse legitimate applications. And whenever we're applying a posture protection or hardening on endpoints with static policies, for example, we're trying to use AI to enhance this posture by dynamically changing, because customer environments are rapidly changing and always not in a constant or fixed posture. So adaptations, exceptions, and auto-tuning are all part of what we call the AI leveraging of adaptive security. When it comes to predictive as well, which is another unique component that mostly is geared towards disrupting attack progression, meaning that we want to understand how an attacker is, for example, executing in an environment or launching malicious code, that we can identify patterns from these executions and identify or recognize what the next action would be and take the required blocking activity to blocking action to disrupt this attack progression. And finally, the Symantec generative AI or agentic AI features that were introduced to the cloud ICDM. We're going to go through each one individually later in the upcoming slides as well. So starting with adaptive security, which is, I think, mostly, or most of you, if not all of you, are well acquainted with the feature. It has been widely spoken of. It's something that it's already being deployed all over our customer bases. And it's quite important to emphasize on the fact of how we use AI with adaptive security. Now, in general, first of all, the challenge that we have across the threat landscape is the living of the land challenge, where we have all of the legitimate applications like Acrobat, PowerShell, or Microsoft Office applications, all of which are being used by all organizations, and all of which have their specific, let's say, application behaviors, or they depict specific behaviors for each customer. Now, the problem is these applications might be misused by attackers. So an attacker might infiltrate or cause damage to any organization or endpoint by misusing those legitimate applications and running malicious scripts or malicious code through these applications. So we really need to identify what good and bad behaviors are, first of all, and have a mechanism to prevent the misuse of these applications. So the main questions that arise is, first of all, can we identify these LOTL tools? If so, if we can identify them, then can we differentiate between what is legitimate and what is bad behavior? And the most important question is, how easily and efficiently can we disrupt or block these living of the land tools that are being misused? And approaching it with a one-size-fits-all is not something efficient. It's not something that would provide any value. Simply blocking everything is not something that will provide us with any value on the adaptive layer. Because each customer is unique, each customer have or exhibit different sets of behaviors from these applications. They each use it in a specific way or form or fashion, and we have to understand how these applications are behaving and take the necessary actions based on the custom requirements for each customer. So with adaptive security, we're offering what we call a unique security for hardening endpoints. We're applying custom rules through a comprehensive list of granular controls on the application behavior policy. And what we're trying to achieve is reduce the attack surface again by granularly controlling how these application behaves, how these executions, for example, are being conducted. Can we allow this set of application like Excel to run CMD or launch PowerShell, or should we take the action to prevent it? So all of this is continuously automated with adaptations and exceptions using artificial intelligence. What we're trying to do as well with AI is to dynamically change the posture of the policy or the adaptive security policy so that it can follow up with the changes that happens with the customer's environment. So it's not only just setting up manual actions on a set of policy or actions and then leaving it for the manual changes to be done later at a later stage where you have to manually review and apply the changes based on the application behavior drift or the different depictions or exhibited behaviors from the application layer, but rather work on more adaptively and autonomously changing it to follow up with the changes that happens. So if we look at the heat map of the adaptive security, this is where all the reporting are showing in the ICDM console. So after a learning period of 90 days, for example, this is when you initially install the adaptive protection policy, it will generate and report back all the detected behaviors of all the applications, legitimate applications within a customer's environment. So for all of these reported behaviors, we do have prevalence for each. So it's either a 0, low, medium, or high prevalence. And with with the prevalence, we're able to identify whether an application behavior is depicted or exhibited in an organization or not. The main aim, again, is to reduce the attack surface, meaning that all zero prevalent behaviors that have not been exhibited in an environment, we can safely block them. And blocking is done through a quick tune option, which with a single click can take the action of blocking and preventing the misuse of these application behaviors. So for example, Excel will no longer be able to launch CMD or launch PowerShell if this is set or within the zero prevalent behavior. Moreover, since this is at the more granular level where we have some of the, let's say, reported behaviors that have been detected and exhibited with high or medium prevalence, for example, we can further fine-tune the policy to apply it only to the people that are allowed to run it. So if C-script is running CMD, for example, detected, we can identify who is running C-script with and launching CMD through C-script and allow only these personnels, for example, to run C-script through run CMD through C-script. So after applying all this locking or hardening on the endpoint, within time, changes do occur. So sometimes application behaviors, new application behaviors are depicted, or old application behaviors that were detected and not blocked, for example, might change throughout time and might be reverted back. So what we need is a mechanism to adapt to the changes that is happening. And this is where we have the system-generated exceptions along with adaptations and auto-tuning functionality and capability. So all of these are dependent on Symantec AI's technology so that we can identify all of these changes and provide recommendations with either automatically deploying them or to submit them for review and apply them accordingly through your tasks manager. So it's more of an efficient way to adapt and evolve with an enterprise changing throughout the time, and it is one of the core features and functionalities as well delivered with adaptive security. So next is predictive incidents. And here we're talking about the prediction of attackers' next move. And it's all, when we talk about the concept behind predictive incidents, we have to talk about the large language models or the artificial intelligence neural networks. These are all technologies that are trained on massive data sets. So they are able to recognize patterns within their data sets, and they are able to always predict what the next, for example, word or context of a sentence would be, all based on confidence and probabilities within the patterns that they have. So taking this and applying it from an attack chain perspective. So for attack chains, they also follow patterns. And we do have a very huge amount of attack chain collections throughout the telemetries that are submitted. And with all the subsequent, let's say, executions within any attack chain, there are always steps that can be identified based on previous patterns that we have seen, based on past behaviors. And with Symantec AI, we can identify these patterns and identify or recognize what would the next step. So that's the concept behind predictive incidents in a high-level fashion. But what's important about it is that it's based upon the cloud analytics feature. So predictive incident is deployed on top of cloud analytics. So it's important to understand how cloud analytics function, first of all. So what we have is a collection of telemetries from all our SEP environments across all the customers. And we have the threat hunter or threat research team in Symantec that are continuously looking for attack chain patterns with through the Symantec telemetry from SEP and other open source telemetries as well. What they're trying to do is, again, identify these attack patterns and label them with specific, based on their attributes, for example. So everything is then ingested into the semantic data lake, where all the attributes are labeled, for example, the file types or the hash of the file, and maybe label it with the MITRE technique that has been used, or the process command line that was used. So all of these labeled telemetries are then ingested into a machine learning training model in the back. Under the data lake, this machine learning model would be trained on all the labels that we have, so that it can identify and recognize what good behaviors look like and what bad behaviors look like. And based on this training, we then come up with a machine learning model that can provide a conviction of whenever we find any new or emerging threat, for example, from any endpoint protection agent. These events are then matched with the ML model that has been trained. Do we see something or a pattern that we already know about? Then, if yes, it will create and trigger an incident that is sent to our customer's EDR console. So in that sense, we've created something based on a collective set of information. Again, we're not looking at only individual set of incidents or events, but we're looking at all aspects of information related to different file activities, processes, command lines, endpoints, and so on. Now, how the predictive incident sits on top of cloud analytics is, since we already have the attack chain patterns, we already have them labeled, we already have all this labeled telemetry in our data lakes, we can ingest those into what we call attack chain embeddings and compare them and match them with already existing and triggered incidents. So these embeddings would create a match, for example, for an incident that we have seen for an attack pattern, for example, that was previously labeled. And the result would be that the prediction of the next steps that an attacker might take is the following application behaviors based on all the attack chains that we have collected and based on all the information that we know about this specific attack chain, for example. And that's when predictive incidents are created and reported back as predicted behaviors under the cloud analytics incident. So we have a list of all the predicted behaviors along with the probability of and confidence of what would be the next attacker's move. And when we have these application behavior predictions, we can apply them on top of the adaptive security. So adaptive security is utilized to deliver the blocking mechanism, again, to disrupt the attack progression by blocking all the application behaviors. So that's it with the incident prediction capabilities that were introduced, and moving on to the generative AI capabilities. So we have multiple use cases that were recently introduced, and some of which have been there for some time but have been enhanced recently as well, including threat description, incident summarization, attack prediction, the attack prediction which we spoke of, and AI assistant, which is the in-product chat, natural language query, and policy summarization, which is still under proof of concept. So for each one, starting with the AI assistant, first of all. And this is the chatbot that is in your ICDF console. Earlier in the V1, it was just a simple generative AI that you ask a question about a specific policy or a specific protection feature, for example, and it would return back some basic information. However, recently the enhancement for the V2 version 2 of the chatbot have expanded to include more of insights and information integration with different, let's say, different agents or platforms, such as the threat intelligence, security telemetry, and analytical tools. So it's more of acting in an agentic form rather than a generative AI. It can go and look all the way through the protection threat intelligence, or through technical documentations and even blogs, and provide you with answers that also correlate to your existing information in your environment. So it's more of a general agentic workflow that combines multiple source of informations to provide you with the most comprehensive response whenever you ask a question. So for example, if we ask it about a specific malware like Latrodectus, it will provide you with an overview of the malware, what this malware is all about, what protection capabilities are there that can block this type of malware by any of the Symantec endpoint protection technologies, and with the complete signature names for these, in addition to any observations in your organizations. Did we see any IOC or artifact for this specific malware in your organization? And if so, it will provide you with the information about whether it was found on how many machines in the last 30 days of your telemetry, for example, and what was blocked and on how many devices. Next, we have the sample submission. This is when you submit files, whether these files are falsely detected in your environment, or if the files have not been detected in a customer's organization. And for the SimSubmit portal, you've always submitted these files and received the report, which at some point of time requires a little bit of analysis to interpret what the conviction is about and what the summary of conviction is about. And now we're using Google models, the latest Gemini 2.5 Flash models, to interpret script executions within files that are submitted. So when you're submitting or uploading a file, it goes through the Google models to be analyzed for all the script execution, and provide you with a submission summary in a human readable text that you can easily understand, along with additional details of all the steps that were observed during the execution. So what the script was trying to do, and all the checks that were conducted, and a summary of the finding on that. Next, we have the incident summarization, and this is something that I personally have been testing on extensively to identify how effective it is. And the outcome is definitely something that is exceptional, in the sense that it accurately can identify or recognize the execution patterns for an incident, for example, and all the artifacts and collective information of an incident, and interpret that in a human readable text with full plain text information or explanation about what happened and how it happened, and all the information related to the attack chain steps, how the execution started, what methods were used, in addition to other remediation step recommendations that are helpful or required to be taken to close and remediate this incident. And then we have the AI-powered natural language investigation, a recent introduction or recent release for the search query, which I personally have been working with lots of customers on building those search queries. And to be honest, it's one of the most extensive activities that you can conduct to build a specific search query to look for specific, let's say, artifacts or IOCs or any threat indicators in our organization. So what you have to do is go through the base template, for example, that is already publicly available, the threat hunting guide, and identify different types of event ID numberings along with disposition, for example, categories, and identify from the events themselves attributes that can be added or removed or compiled into the search query so that we can come up with something meaningful that can be that can provide us with what we are looking for. Now, with the natural language investigation, we're using AI to translate human text or natural language into the actual search query that can report back to us what we're looking for. So for example, we can input things like find privilege escalations in my environment, which is translated into the actual search query that can be used to report back all these privilege escalations. Or show registry updates for COM hijacking, or find events where a scheduled task was launched. So a very efficient and easy way to overcome all the complexity of the search query buildup that uses lots of time and effort to be compiled, and then if you require to modify them, then you'll have to go through one set of large, for example, search query that would take time. And definitely with natural language investigations, we are able to overcome that. So with that said, that was a quick and brief highlight on all the Symantec AI capabilities that were introduced. I'm going to go through a quick demo to showcase the predictive incidents use case, along with some of the features that are available on the cloud for the generative AI as well. So let me just okay, I hope that you all can see the screen.
Yes, Ahmed, we do. Thank you.
Okay. So let's quickly go to the incidents tab, and I do have one of the cloud analytics incident that is triggered. Again, cloud analytics is the effort of both the Symantec AI models along with the Symantec threat hunters or threat research team. So the collective information that was gathered for this malicious activity has been reported back, and we can start seeing the Symantec AI generated summary. This is where all the human readable text explanation summary that has been generated for this specific incident, which shows us, for example, this incident involves the execution of Mimikatz on the host, which is named client-02. It explains about what Mimikatz is. It shows us that the parent process is explorer.exe, which is a standard Windows process, but the involvement is highly suspicious. Some of the attack chain analysis, what the execution and process command lines look like, key observations, user intent, and all the remediation steps required, along with the application, predicted application behaviors, which we're going to go through now. So again, we have this client machine running Mimikatz tool, which is well known for credential dumping and stealing credentials. Symantec AI was already able to summarize everything in a human readable text that we can understand from, and predictive incident as well was able to identify the next behaviors that are most probably going to be executed. And here you can see, for example, when Mimikatz is running, based on the attack chain patterns that we have collected and based on the telemetries and that the data sets that were already put into machine learning models, as we mentioned earlier, we're able to identify and recognize these attack patterns because we know how Mimikatz works, we know how it executes, and we know what would be the next steps, for example, to be executed. So registry edit dumping credentials at SAM registry, very well known and something that is to be executed afterwards, along with, for example, untrusted process accessing memory for LSAS for dumping credentials, and various other PowerShell activities. So with all the confidence that was provided, for example, probabilities for all these application behaviors, as we said earlier, for incident predictions and for all the cloud analytics incidents, we can instantly take the action by blocking the behaviors. So if we go to block the behaviors, which as per my previous test, I already blocked them. So sorry for that. Let me quickly go to the policies, adaptive protection, and quickly check. I think I didn't revert back that. Sorry for that. So I'll just find one of the behaviors, or let's say just for PowerShell for demonstration purposes. Okay, save that. Okay, and go back to the incident, go back to the cloud analytics incident, expanded, and to the block behavior. So we select the adaptive protection policy that we want to apply the blocking for, click on next, and then we have an automated list populating for all the behaviors that were detected. The type, as you can see, is predicted. Minor attack techniques are mapped to each of these application behaviors along with the prevalence. How many times have we seen this behavior in the organization? Prevalence is crucial to identify whether this is something that is being used or something that have never been used by any of our endpoints. And when it's referring to zero prevalence, it means that none of our endpoint machines in this environment, for example, have depicted or exhibited this application behavior. So it should ideally be blocked at the first place. Click next and save and apply the policy, and with that it will take the action to block all of these application behaviors. Apply them to the adaptive protection policy, go back to the PowerShell, and we can see the deny action applied to this policy, which in return is applied to all the machines, and in essence, we're effectively disrupting any execution of these when Mimikatz have already launched, and all of these sequential type of executions might happen. We are preventing them from occurring or blocking them from the activity. So that was in regards to incidents and adaptive security. And we've covered the Symantec AI generated summaries. One of the search queries as well, which is now available if you go to the ICDM as well and click on the Symantec AI query. This is the feature where you can input natural language investigation queries, which gets translated into an actual search query that will return results for you. So for example, show me all PowerShell activities with invoke web request command. And if we click on translate this, it will automatically.
Protection engine, or it went to end of life.
Protection engine is absolutely living. Yeah.
You're unmuted. Okay, so we run the query, and ideally it should provide us with some process activity for PowerShell with process command line invoke web request. If let me try it on because some of the events are not all populating on the same domain. So I believe that if I run it in my MetaLab here, okay, so show me all PowerShell activities with invoke web request, translate. Hopefully this will return some results and run the query. Okay, and here we can see all these returned. It translated the natural language query into the actual syntax of the ICDM investigate query, and we can see the actual command lines, for example, for these PowerShell execution. If you look at the PowerShell, and here we see in the active command line, it includes an invoke web request. So again, one very useful feature to be utilized for threat hunting and investigation, which can help us in that sense to easily build up our search queries and look for what we're trying to search for and get efficiently all the results that we need without spending the time in building up all these complex search queries. So I think with that said, that would be the end of the quick demo, the brief and high-level demo on both the incident predictions and the other AI technologies that were introduced. I'll leave it now if anyone has a question so that we can maybe answer them accordingly. If you have any questions, please do raise them now.
Looks like we don't have questions for now.
Yeah, that was quick and brief. I didn't expect to be finished at earlier than the expected time, but
yeah, but thank you so much, Ahmed, for such an insightful presentation, and thank you all for joining today's webinar. I think we had some questions now. So is there any demo site for Playground available?
Playbooks and customizations. For the playbooks, we have the default playbook presets. So if you go to the My Tasks page, you have these more of protection-related playbooks that can be applied for general functionalities like running full scans, quick scans, live updates, but nothing that is customly configurable or that can be applied to specific measures or things that might be related to the AI functionality. Nothing yet that is available in that sense for that. So only we have these pre-built-in playbooks that can be used. Any demo site for Playground available? So demo sites, I think these are maybe part of NFRs that can be requested for having access to ICDM, for example, and you can have the option to go and work and demonstrate or test out all these functionalities. So that's something that maybe May can help in answering for requesting demo and trial licenses. And we have a question about integrations with SOAR, which is for orchestration and automation. An excellent question. So I'll answer on this a little bit extensively because one of the key use cases when it comes to SOAR is to automate actions and response actions for specific based on specific conditions or requirements. And that is absolutely possible through the REST API capabilities. We've done this with multiple customers, with QRadar Source, for example. What you can do is, we do have this Symantec API console. If let me just quickly, Symantec API console. So it's publicly available. You can, sorry, not this one, API documentation. So it's publicly available for everyone to check out for all the Symantec and cybersecurity products where we have categories for all the APIs that can be used, all the REST APIs. And the use cases when it comes to SOAR is always to fetch events, first of all, and within the SOAR, you apply all the conditions and rules that can be applied, and then based on the output of the condition, you take the actions that are required, for example. And all of these capabilities are there. You can look into the event stream to collect all the information, for example, apply the condition filters and everything required based on all the telemetry that you're collecting. And then you can add information or apply changes to your devices or device groups and device commands to either implement hashes or, for example, add IOC hashes or take actions based on policy changes that can be done through the API commands or API REST API commands that can be initiated. So definitely a feasible use case that can be done through that. So Milan asking about for demo of the services that we can test and get familiar with. So yeah, if my understanding is correct, Milan, you're asking about having access to a demo environment, right? And for that, I think it's part of acquiring a trial license where you can get access to ICDM. So you can initiate a request for that, and definitely we can have it and have access to the environment and test out. Yep. Any other questions? Okay, combinations to go towards XDR. Good question. So XDR, if we want to talk about the what I would refer to it as the V1 XDR approach in Symantec Endpoint Security, and this is where we configure integration with CASB, with the cloud subtenant for extended detection and response. Now, what we're essentially doing is expanding on the events that are collected from an endpoint perspective only to other types of events that include DLP, that might include network events, and all the cloud SOC events that can be ingested for the all the securetlets and gatelet access, for example, and eventually get an incident with all this enriched event context in a single pane. Now, this what I would consider is the version 1 of the XDR offering that is currently available within Symantec. However, the work is being done for the Symantec Enterprise Cloud, which eventually is going to be the ultimate XDR approach, which encompasses all the Symantec product portfolios, the major ones like Endpoint Security, Web Security Services, CASB, and DLP, for example, all consolidated in a single enterprise console with a single incident pane, which is something that is within already in the roadmap and being developed and worked on. Hopefully, that is something that Broadcom is committed to achieve in the future, and that's where we're moving towards in terms of, let's say, the consolidation and the enterprise cloud. But for now, the XDR capability is strictly on the integration between the endpoint ICDM and the cloud subtenant that can enrich additional events and context for XDR visibility. I hope this answers the question, John. Managed services is not yet an option. What I would say, it's more of, because when we're speaking of managed services, the goal or the ask is always to have someone looking after your environment and maybe taking actions whenever it's feasible, right? In itself, as a service to be sold out to customers, that's not something that is yet available, or that might be available maybe in the future. That's not what I can answer on. But what I could say is, in the form of managed services, Broadcom is already offering part of the cloud analytics effort that we spoke of. So that's both of semantic artificial intelligence in parallel as well, working with semantic threat hunter researchers who are acting as a SOC analysts that are sitting in customers' environments and creating and triggering events or incidents based on the custom telemetry that we receive from these customers. So in a sense, it is some form or sort of managed services that is applied for customers that already comes free of cost and within the endpoint security solution. In that sense, I would say it's some sort of an offering of a managed services, but not an isolated or dedicated managed service that is sold independently. Most welcome. Any
Perfect.
other questions? Yeah, sorry, May.
Yeah, I believe we don't have further questions.
Yeah. I think.
All right, perfect. All right, so thank you so much, Ahmed, again for such an insightful presentation, and thank you all for joining us today. So please take a moment to complete a short survey at the end of the session, since your feedback is really appreciated. And also the recording will be shared with you the soonest. If you have any further question or if you would like to schedule a demo, you can reach us at info@mbcom. We appreciate your time and we look forward to see you in our upcoming sessions. Thank you so much, everyone.
Thank you, May. Thank you, everyone.
Take care.